Here's another fun problem. I've got lithium hydroxide. It's once again a group 1 metal, an alkali metal, lithium, attached to hydroxide, which means that it's a strong base. It'll dissociate virtually 100% to form lithium and hydroxide 1-to-1 stoichiometric ratio like this. I've been asked to calculate the hydroxide ion concentration and, and the pH, sorry, the pH. It tells me that I've got 2.25 grams of this, and I've got it in 250 milliliters of solution. How do I determine what the hydroxide ion concentration is? Well, that isn't too bad. I've got 2.25 grams of lithium hydroxide. I need to figure out how many moles of lithium hydroxide that is. So I've got 1 mole of lithium hydroxide is equal to 23.9 grams. Grams cancel each other out, and I end up seeing that I've got 0.094 moles of lithium hydroxide. Now I'm going to jump the gun right here a little bit. If I've got 0.094 moles of lithium hydroxide, because the lithium hydroxide and this hydroxide are present in a 1-to-1 ratio, that means that I'm going to get 0.094 moles of hydroxide coming out of this equation. I've got that many moles of hydroxide. I need the hydroxide concentration, which is moles of hydroxide divided by liters. How many liters do I have? I've got 250 mils. If I divide that by 1,000, that gives me 0.250 liters. So 0.094 moles of hydroxide divided by 0.25 liters is going to tell me what the concentration is of hydroxide. That ends up coming to be 0.377 molar. That's my concentration for hydroxide, so I'll write that up there, 0.377 molar. What's the pH? Well, once again, I'm going to get to pH by going through pOH. pOH is equal to the negative log of the hydroxide concentration. I can replace the hydroxide concentration with my actual number here, so I've got 0.377. I throw that into my calculator. I end up determining that the pOH is equal to 0.424. How do I get pH out of that? Well, pH plus pOH is equal to 14. I've got my pOH, I throw it in here, rearrange it algebraically, and I can get my pH.